Hello, welcome. Today's lesson is on sampling statistics. Going to talk to you about sampling. It's a huge part of statistics, like polling or anytime where quality control, where they take samples out of the population to check the statistics. So hopefully that'll all make sense what I'm saying once I go over this. But first, there are four key terms that I want you to know for the first part of what we're doing. And first one is the population. And the population, when we're talking about a sampling, the population is just the entire group of which your group of individuals or items. Individuals don't always have to be people in statistics, but it's the group of individuals of which we want to be informed. So if you're doing a study on the students of Independence High School, then that's your population, all the students of Independence High School. If you're doing a study on the high school students in Mecklenburg County, then your population will be all of the high school students in Mecklenburg County. So if you're doing quality control for a company that makes brake parts, then your population would be all of the brake parts that they make in that batch or whatever. And then the sample, that's the part of the population from which you actually collect the information. So your sample is going to be usually smaller than population, and there's different ways you can get your sample. But like you're saying with the brake parts, maybe you take one brake part off the line every hour and test it. That would be your sample. You're not going to test every single brake part, or you're not going to poll every single person. Now there are situations where you do poll or sample every single piece of the population, and if you do that, it's called a census. And a census, and we do it every 10 years in the United States, where every single person in the United States is supposed to be counted. But that's not the only census. A census is just a word that means you are sampling the entire population. Okay. The word parameter. That is going to be the number or the proportion that describes the population. Sometimes it'll just be an unknown parameter. We won't know the actual statistic, the actual proportion for the entire population. Sometimes there will be a guess of what we think the parameter is. And then the statistic, it's going to be the matching number or proportion or percentage that describes the sample. And we use the statistic to make inferences about the population and what we think the parameter would be. But our statistic, unless we do a census, is never perfect. So we're going to talk about that too. So here's our first example. Ketchup bottles. On Tuesday, the bottles of a tomato ketchup filled in a plant were supposed to contain an average of 14 ounces of ketchup. The quality control inspector sampled 50 bottles, so he went down and just randomly took 50 bottles out of the production and found out that these bottles contained 13.8 ounces of ketchup. So what's the population of this statistic? Forgive the phone ringing. We'll just ignore that. So he's testing on a certain day. So the population for this is all ketchup bottles filled on Tuesday. Right? He's not worried about any other day. We're just testing for Tuesday. So all the ketchup bottles that were filled that Tuesday, that's our population. The sample is the 50 bottles 50 bottles that were tested. What's the parameter? Well, the parameter is what we think those, so it's the 14 ounces per bottle that we think they should have. And then the statistic is what they actually had, just the sample, which was the 13.8 ounces per bottle. And that's it. So those four things in a study are important to be able to identify. So example 2, same thing. If you want to go ahead and pause the video and try to figure this one out, and then we'll come back to it. Alright, so if you've unpaused to check your work, so a U.S. Senator claims that the majority of adults prefer balancing the budget over cutting taxes. A poll of 1,190 adults finds that 702 prefer balancing the budget over cutting taxes. So, population. A U.S. Senator claims that the majority of adults, right? So we're just going to say U.S. adults. All of them, right? The sample then is the 1,190 adults that were in the poll, right? The parameter. So he claims that the majority. So the parameter is that more than 50%, right? Want a balanced budget. The statistic, we could say that the 702 that prefer a balanced budget, but since this is a proportion or a percentage, we might think of this as 702 out of the 1190 that prefer a balanced budget. And we could change that to a percentage or just a decimal, but that is your statistic. If you just said 702 people that prefer, that's not wrong. So, all right. So, if we think about this one, I'm going to go ahead and 702 divided by 1190, that's close to 59%. So like I said, we can pretty much say, or the poll shows us that 59%, so yeah, more than 50%, but 59% prefer a balanced budget. But since it's a statistic, there is some error there that it's not always going to be a perfect number, right? If you called up 1,190 different people, then you probably wouldn't get exactly 702 the second time that prefer. And it's going to be a give or take. And that's what we call the margin of error. Now, for a simple poll like this, we are going to do the margin of error to what's called a 95% confidence, which means that we believe that 95% of the time that this poll is done with 1,190 people, that we're going to be in a certain confidence range, right? That our poll is going to show us that it's between these two numbers. And that's called the margin of error. And to get that margin of error, it's always 1 divided by the square root of n, where n is your sample size. So your sample, that's n. So in this case, make sure I In this case, the margin of error is 1 divided by the square root of 1190. 1 divided by the square root of 1190 is 2.9, pretty much. It's about 2.9%. If you see on the calculator, it's 0.028988. So move the decimal and round that, 2.9%. So we could say that we are, for this one, we are 95% sure that if we do 59 minus the 2.9 and 59 plus, we're pretty sure that, or we are 95% confident that if we redo this poll, we're going to get anywhere from 56.1% to 61.9% of the people wanting to balance the budget. So do you think the U.S. Senator is right that more than 50% of the people, based on this study? Yes. So let's look at example 3. And if you want to try this one before I do it, great. There's another example like this. So the Gallup webpage contains a press release titled "Americans Dissatisfied with U.S. Education in General, but Parents Satisfied with Their Kids' Schools." So the release described a survey conducted of 1019 U.S. parents, in which 561 of them of the surveyed parents said they were dissatisfied with the U.S. education in general. Right. So, what is the margin of error for this study? So it's just going to be 1 divided by the square root of 1019 is your sample size. Because our population is all U.S. parents, right? Our sample is the 1,019 U.S. parents. The parameter, I don't know, the parameter would be the percent of parents, the percent of all parents dissatisfied with, right? And then your actual, like your statistic is that 561 of them were dissatisfied. So first, our margin of error, 1 divided by the square root of 1019. So it's about a 3.1. We'll just do 3.1%. And that's, margin of error is always a plus minus kind of thing. It's on both sides. So what's the 95% confidence interval? Well, first we need to find out what is the percentage that said they were dissatisfied. So 561 out of the 1019. So about 55% of the parents said they were dissatisfied with the U.S. education in general. So our confidence interval is going to be 55 minus our margin of error, 3.1, and 55 plus 3.1. So we can say that anywhere from 51.9% to 58.1%. So make a 95% confidence statement about this. So we have a 95% confidence that 51.9% to 58.1% of parents are dissatisfied with U.S. education in general. That's all it is. So you need to know your margin of error. Use the formula. Your confidence interval is whatever your percentage is from your survey, plus or minus the margin of error. And then you can write it as a 95% confidence statement. All right, so example 4 is the same thing, just different data. So try that one. See if you can get those. Pause. Okay, so we're back. In 2004-2005, the NHL owners locked out, ended up in the cancellation of the 88th season in the NHL as the first time the Stanley Cup, which is a championship, was not awarded since 1919. So they canceled the season. This is back in 2005. So if any of this stuff we're doing seems old, it is. In 2005, the Gallup poll asked a sample of 620 Canadian adults whether their support of hockey had been affected by the recent lockout, and 248 of them said yes. So 248 people were bothered by the lockout. What's the margin of error for this study? So again, if you think about it, our population are Canadian adults. Our sample is 620 Canadian adults. So 1 over the square root of 620 will give us our margin of error. We don't have, so our parameter, if you were asked what the parameter is, it's not a specific number, it's just the percent of Canadian adults who were affected by the recent lockout. And then this statistic is the 248 out of the 620 that said yes. And we'll figure that out. So first, 1 divided by the square root of 620, that has a 4, we'll just call it a 4% margin of error. Now the last one was, come back, only 3%. So when you have a 3% margin of error from the middle, you're going 3 in each way. So a 4% margin of error is a wider margin of error, because this is 3% and that's 4%. Well, the first one we talked about, we only had a 2.9%, so even smaller. And if you look at our sample size, 1190 is bigger than the 1019, which is bigger than the 620. So when you reduce your sample size, you are actually increasing the margin of error. So the bigger the sample, the smaller the window or the margin of error is going to be. It's going to tighten up that window. So we know it's going to be plus or minus 4%. So 248 divided by the 620, that's 40%. 0.4 is 40%. So 40% of them said they were effective. So our confidence interval would be 40 minus 4. So anywhere from 36% to 40 plus 4. Right, because you're doing plus or minus the 4%, 44%. So if you're going to make a statement about that, you can say, we are 95% confident that 36% to 44% of Canadian adults were affected by the hockey lockout. Yeah. Well, I can't read that, but I hope you can hear what I'm saying. That's it. So that's parameter, population, sample, statistic, margin of error, 95% confidence interval. So we'll look at one more of these that has all the parts to it. So national sample surveyed 38,000 people, age 18 or older, nationwide by telephone. One question asked whether they agreed with this statement. One question asked whether they agreed with this statement. Some people say we should have a third major political party in this country in addition to the Democrats and the Republicans. Like I said, this was written all the way back in like 2006, the stuff I'm getting. So this is old. Seems pretty contemporary, but no, this is way old. Of the people asked, 53% of them agreed that we should have a third party. So what's the population of this one? National survey interviewed people age 18 or older. So it's all nationwide, so all U.S. over or 18 or older. What's the sample? That's the 3,800 people from that population. Important that the sample has to come from the population. So if you're doing this survey and you call up and a 15-year-old answers the phone, they can't be part of the survey. They don't represent the population. So it has to be people over 18. 18 or older. What's the parameter? Well, we don't know the parameter. We just would say the percent of people who want a third party. That's really what the study's trying to find. What part of the population would like to have a third party? What's our statistic? Well, they didn't give us where we had to find ourselves. They just told us the percent. So 53% is the statistic. 53% of the people want a third party. So what's the margin of error for this one? So it's 1 divided by the square root of the sample size. That's our largest sample size we've had so far, so it should be our smallest margin of error. And it is. It's about 1.6%. So it's going to be plus or minus 1.6%. So our confidence interval, we already know the 53 is going to be 53% plus or minus the 1.6%. So 53 minus 1.6, 53 plus 1.6, anywhere from 51.4 to 54.6% is our 95% confidence interval. So we can say we are 95% confident that 51.4 to 54.6% of U.S. people 18 or older would like to have a third party. And I wonder what it is today. All right. So that will take you through the one assignment that's just on confidence intervals and population and stuff like that, the first assignment. The second assignment is talking about bias. I don't know if you talked about bias before, but there are some terms I just want to go over so that you can answer the bias worksheet. So first off, anecdotal data. You hear about, and a lot of people use anecdotal data as information about one individual, but absolutely nothing about the population this individual represents. Some people call it a one-off if you watch the news. And what this is, anecdotal data, is when somebody tells you, the majority of people, seatbelts is a good one, right? So like seatbelts save lives, that, wearing your seatbelt is going to save you in a car crash. And then you'll have that one person, I know somebody that wasn't wearing a seatbelt, and because they weren't wearing a seatbelt, they survived the crash, and they would have died if they were wearing. That's a one-off situation. That's an anecdotal. It is not representing the majority of all of them. So when people say like, my brother's cousin's nephew had, they are giving you anecdotal data. It is not part of the population, or not part of the sampling statistic we're finding out. So bias, and that's what this is talking about. In anytime there is bias in a sample or bias in a statistic, it is a systematic favoring of certain outcomes. So if you're doing a statistic and you want it to show that the majority of people want this or don't like that, you can use bias. You can use ways to make that happen. And this is not good. You should not have bias in any statistic, because it doesn't represent the true feeling. And there's a lot of different ways that bias can happen. Questioning or wording bias, which is bias created by the wording of a survey. I don't know an exact example, but if the wording of a survey makes people feel guilty for saying yes, or feel guilty for saying no to the survey, or if the wording makes them question what their answer should be, that's bias, and that should not be in there. Questions should be just straightforward and let people make up their own minds. Undercover bias is when you don't get the opinion. So if your population is all the people in the United States, and you know that people from West Virginia, my home state, don't like something, so you make sure you leave them out, then that's undercoverage. You are purposefully leaving somebody out of a survey that is part of your population. A good survey will have representation from all of the population. This isn't bias. Those are our bias. Your sampling frame, that's just like talking about the ketchup survey at the beginning. The sampling frame would be all of that ketchup, and if you had like each bottle numbered or labeled, give me bottle number 20, number 28, and whatever. Or if you have just a list of your entire population, so if it was a survey of the students at Independence, I could just go get a list of all of the students. That would be my sampling frame. So frame, it's just in your frame is your entire population. Variability is just how spread out the values of a sampling statistic are. So you might know what the average is, and the average will tell you the middle, right? And we've talked about this before. The variability, when you talk about the spread, that's important too. How spread out that data is. So I will post this online if you need to see it. And so there are 2 assignments to go along with this lesson. Do both of them. Good luck, and have a great day.